In this video, we're going to talk about 7 different types of parent functions, and then for one of the examples, we're going to talk about how you would find domain and range of that function, and then the intervals for which that function is either increasing or decreasing, okay? Now, a parent function is the simplest form of whatever function is you're looking at. For example, if I'm looking at a linear function, the simplest linear function is y equals x, and that is going to give us this line right here, right? Now, I can do things like I can say y equals negative 2x plus 2. It's still going to be a line, but it's going to look a lot different than the one we have. But the shape is still going to be the same. It's going to be a straight line. Okay. Another one that we have is the quadratic function. The simplest parent function form of that is y equals x squared. So what we need to look at here is the x squared. If I have an x squared as my highest exponent, I'm going to get that parabola or U shape. So I could have a different function like this, x squared plus 4. It's still going to be U shape, but it's going to be shifted or reflected or stretched or compressed. It could be do a number of different things, but the shape, that parabola, is still going to be the same, and that x squared being the highest exponent is what tells me it will be a parabola. The absolute value function is when I have the absolute value of x, that is going to give me this V shape. All right, absolute value is just the distance from 0. So if I had absolute value of negative 6, you have to ask yourself how far is negative 6 from 0, and that is 6 units away. So the absolute value of negative 6 is 6. And similarly, the absolute value of 6, positive 6, is going to be also 6 because that is 6 units away from 0 as well. So a lot of people like to say, well, you just drop the negative. And while that's true, the idea, what you're doing is I am simply finding how far something is from 0. That's absolute value. So if you saw something like this, y equals the absolute value of x plus 1 and then minus 3, it's going to be the V shape, but just translated or reflected or stretched from the original V. All right. The cubed, we have a similar thing here. We have y equals x cubed. That is what we're looking for, and that will give us this kind of curvy S shape, right? So if I had something like this, x cubed minus 7, that would still be the same shape, just in a different spot on my graph. Here we have y equals the square root of x, which would give our square root curve, a sideways, half of a sideways parabola. So anytime you see the square root of something, square root of x minus 8, right? That would give me the similar shape of a sideways, half of a sideways parabola, but just in a different location. The rational function is going to be when your x is in the denominator, you're going to get this little boomerang shape here in either quadrant, or we could have something like this, 1 over x plus 1. This would indicate that it is a rational function because I have the x in the denominator. And then the last one, we have the exponential function, and you guessed it, x is in the exponent. That's what makes it exponential. And what we're going to do is we're going to see some sort of growth right here. And if I had something different, if I had 4x and then plus 1, x is in the exponent, so I'm going to get this shape right here, or one similar to it, just translated around a little bit. All right, so now let's look at the quadratic function here. We know that the quadratic function is this parabola U shape, right? So now let's look at what a domain or range could be of this particular parabola. And we're going to talk about where we can have intervals of increasing and decreasing parts of this function, right? All right, so now we're going to look at the domain values. So domain are all possible x values, so I'm looking at going left and right only. So how far will this parabola go left? And some of you are thinking, well, coach, that parabola just goes up both directions. Well, that's true, but it also goes left a little bit as we go this direction, and it also goes right a little bit as we go that direction. So the question is, how far right and left will it go? And the answer is that it will continue on forever, both to the left and to the right, right? So as long as I continue up, that parabola will continue to get wider and wider, and the same thing is true for this side. As long as I can keep moving to the right. So the domain in this case is going to be all real numbers, okay? So this is just the symbol for all real numbers. That's a little R with a double line on there, okay? So now let's look at the range. Range is going to be all possible y values. So we've already determined that this graph does go up, right? I've got two different legs of this thing going up, so it will go up forever, but the trick is it does not go in the downward direction forever. It stops right here at this spot here, and changes directions. So the question is, how far down the y-axis will it go? And that is, it stops right here at 0. So what I'll say is y is going to be greater than or equal to 0. That would indicate I have all positive real numbers. Okay? All right, and the next thing we're going to write is we're going to talk about the decreasing sections of this graph. And to determine decreasing or increasing, we're going to read this graph left to right. All right, so if I start here on the left and I start moving across this function, I'm going in the downward direction until I get to right here at this 0. So intervals are going to be determined by x values, right? So as I keep going this way, the x value that I have over here is negative infinity, and that continues on until I get to 0, and then it stops. And once I get to 0, I start increasing again, okay? So the decreasing section of this function, I'm going to do this two ways here. I'm going to do interval notation and inequality notation. I would start at negative infinity and I would go to 0. Now, I'm going to use the bracket here because I want to include 0 because I'm still decreasing when I get to 0, but the infinity would be don't include it, right? And since negative infinity is technically a number that keeps getting smaller and smaller, I can use the parenthesis there instead. All right, and you could also write this in what's called inequality notation, and I would say it's decreasing when x is less than or equal to 0. Okay, then when we look at the increasing side, right, when I get to the 0, I start to move in the upward direction, so this part of the graph would be increasing. So I'm going to write it in two notations as well. So here I would start at 0, and I use the bracket because I want to include it, and then I would go to infinity, and because it's infinity, I'm going to use the parenthesis, or you could write it as when x is greater than or equal to 0, we will be increasing. Okay, so now your job is to, on your own, go through and determine the domain and range on all of the other 6 parent functions, and then you're also going to find the increasing and decreasing intervals. All right, hope this video helps, and we'll see you in the next one.